Continue with chapter 12, exercise 12a, mensuration of 2D diagram. Question number 15. We have a circular park whose diameter is 40 m. If the diameter is 40, that means 42, radius will be half of it. Half of it will be 21. Okay. Then what happened? It has a path running around it. So there is one path outside. And the width of this path is 3.5 meter. So here again we have two circles. One the inner, one is the outer. Inner circle we get radius 21. Then the width of this two, the distance between these two circles is 3.5. So that means the outer radius will be 21 plus 3.5. So it will be 24.5. Then what we have to do, we have to find the cost of traveling. So that means they'll put stone only on this ring. So that means the amount of stone required will be equal to the amount of the area present in this ring. That means we can find it out using area of outer circle minus area of inner circle. Then after that we can calculate the cost. So let us take those. Diameter is 42, radius will be 21, the width we know 3.5. So that means the outer radius will be 24.5. So now area of the path we can get outer circle minus inner circle. So pi r square those minus small r square. Okay, we can take common pi. Then capital R we have 24.5. Small r we have 21. Then here we can apply a square minus b square. So it will be a minus b, a plus b for easy calculation. Here we can minus 5 is decimal, 21 no decimal. So 24 minus 21 will be 3 with 0.5. Then 24 plus 21, 45.5. 7 divide here, we have decimal, so 0.5. We multiply all this, we get the area to be 500.5 meters square. Then the cost for putting stones, they already give us 1 meter square, it will cost rupees 20. Then for this one, 500.5 definitely will cost more. So we have to multiply. So 20 into 500.5. So the amount of money required will be 10,000. It will be 10,000, 10 rupees. Then we will go on to the next question. We have, there is a square whose side is 10 cm. We have to find the area circumscribed and inscribed. Circumscribed means we have the square, then the circle will run around the square outside. Okay, so in this case we clearly see that the diagonal of the square will become the diameter of the circle. So in order to get the radius, we have to find first the diagonal of a square. So we know that in a square each angle is 90 degree. That means we can apply Pythagoras theorem. All sides of a square are equal. So in order to get the diameter, we can find the diagonal using Pythagoras theorem. So if we draw it that way, okay, you can roughly draw the figure. Then remember here the diameter of the square will be, the diameter of circle will be the radius, the diagonal of square. Okay, we can join this one. Then this angle we know 90 degree, angle of a square. So we can apply Pythagoras theorem. So it will be AC square equal to AD square plus DC square. AC we don't know, let it be there. AD we know 10 square here also. So 10 into 10, 100. 100 plus 100, 200. If we split it, then 2 can go out, root 2 there. So this is the diagonal. Then if we want the radius, we have to divide by 2. So 10 divided by 2 equal to 5. So that means the radius is 5 root 2. Okay. So the area of the circumscribed circle, it is pi r square. Pi we know 22 by 7. r, because square, let's write it 2 times. 5 root 2 into 5 root 2. Then 5 into 5, 25. Root 2 into root 2, 2. We multiply all this, we get this one. We divide by 7. You can take at least 2 number after decimal because it is not a perfect numbers as to say. Then next we have the inscribed circle. When we say inscribed mean the square will be outside, the circle will be inside. So if the circle is inside, then we can clearly see here that the diameter, okay, if you join from here to here, we will see that the diameter of the circle will be equal to the side of the square. So that means it will be 10 cm. So radius will be half of that. That is 5. So area of the inscribed circle, it will be pi r square. Instead of r, you replace with 5. So multiply or divide, you will get the answer. Then next question number 17, we have the area of circle inscribed in an equilateral triangle. So we have equilateral triangle. Then inside this equilateral triangle, we draw one circle. We draw one circle. So the area of circle already given to be 154 cm. We have to find the area of the perimeter of the triangle. Okay, the area of the circle is given to be 154 cm square. We have to find the area perimeter of triangle. To get the perimeter of triangle, we know that it is 3 into side. So first we have to find the side. Okay, those. So here we have the area of circle given inside the triangle is 154 cm square. Let us try to get the radius. So formula for area is pi r square. Pi we know it is 22 by 7 into r. So this 7 you can take up. This 1 we can take down. If you divide here. So we want only r. We can put square root. R equals 7 cm. Then remember the circle is inscribed inside the triangle. So that means here, okay, we can see that if we take this as the height, it will be equal to from here to here 1 radius, here to here. So here we'll have 3 radius equal to height. Okay, the height of the equilateral will be 3 into radius. Then radius we know it is 7. So the height is 21. Then we know the formula for height of equilateral to be root 3 by 2 side. Because in order to get the perimeter, we need the side. Okay. So this 2 which is down, we can take up. Then root 3 which is up, we can bring down. So the side will be 42. Okay, then root 3 we can rationalize by root 3 up and down. So root 3 into root 3, 3. Then here it will be 14 root 3 cm. Then next, remember we want to find the perimeter. So perimeter, we know that it is 3 into side. So 3, then side we get from here. So 3 into 14 will be 42. Value of root 3, we know it is equal to 1.73. So multiply, you will get the answer. Then we will go to the next one. Here they say again we have concentric circle. So that is one circle inside, one circle outside. Then the area between the two one. So that means area between the ring equal to 770 cm square. The outer radius we have 21. We have to find the inner radius. So since concentric circle, that means it will take the shape of the ring. Okay. So if you take the inner radius to be small r, the outer to be capital R. So area for this ring will be pi r square minus pi r square. Okay. So those. Then pi we can take common. So here capital R we know 21, small r we don't know, let it be there. Then this 7, we can transfer that side, 22 also up, we can bring down. 21 into 21, 441 minus r square. So 22 divide here, we get 35. 35 into 7, 245. This is plus, has no r. We take that side, become minus. So if minus, we get this. So minus cancel for both sides. R will be square root of 196. Square root of 96, we know it is equal to 14. So the inner radius is 14. So those 196, to find the square root, you can use long division method. Okay, those 1 into 1 1, we have to go with perfect square. 96, 1 plus 1 2, so 24 into 4 will be 96. So that is how we get the inner radius to be 14 cm.